Okay, so in this video, we're going to learn about hypothesis testing and how it works. And so we're going to transition from z-scores of the normal curve, its central limit theorem. Hopefully you know all about that and you've watched the video on the central limit theorem. But what we're doing is we can take what we've learned and sort of apply it to some special cases. So let's talk about the z first of all. So if you remember, the z was equal to whatever the score was minus the mean, and all of that was divided by the standard deviation, right? And I'm going to put the divided by the standard deviation. That was our basic z-score formula. Well, as it turns out, because the central limit theorem says a sampling distribution, right? Remember, the sampling distribution is a normal distribution of sample means. Well, that means that we can take this information and apply it to a population. So if we have a population, that means that if we sampled from this population over and over again, we're drawing samples from this population. So if we sample from this population, our sampling distribution will be normally distributed, right? And that means that if we draw two samples from this population, they'll be pretty similar to one another. As a matter of fact, what that means is, use your knowledge about the normal curve, right? The mean of the sample means, right? The mean of the sample means, right? Which will get closer to the population mean mu, will be here in the center, right? And then we know that 95% of our sample means will be between plus and minus 2 standard deviations. Right? This is just so far, all the stuff that we have learned before, sort of in review. So what that means is that we could take this sample and we could find out what's the likelihood that it belongs to this population applying that logic. So we draw a sample and we could essentially compute a z-score, but instead we're talking about, we're going to compute a z-score, right? But now, instead of an individual score, we're talking about a sample mean, right? And now, instead of a sample mean for the mean, we're talking about really the population mean, right? Because we're comparing it to the population mean, and we're going to divide by the standard deviation, but we're not dividing by the standard deviation of a particular sample. Instead, we're dividing by the standard deviation of a population, which we use sigma to represent that. So, right, so if that formula would, in effect, create a z-score, and if the z-score is 1.96, or plus or minus 2 standard deviations, if it's within that range, we would say that it's likely belongs to the population. If it falls out here in these tails, we would say that it likely belongs to some other, right? Other population, right? And ditto here. If it falls way out here, if it's a very positive score, also some sort of other population. So in this way, we could determine probabilistically, we could make a probabilistic judgment as to whether or not this sample belongs to this population or not, just from computing a z-score, such that if we have here, I'll use this symbol here. So if we had 0.025 here and 0.025 there, we would have a 5% chance, 95% chance of being correct when we assume that it belongs to the population, 5% chance that it belongs to some sort of other population. So we can begin to make these probabilistic judgments that any particular sample taken from this population belongs to a particular population. So that's essentially the basic logic. Now, what we can do is we can take it a step further and then begin to compare two samples. And so we'll talk about examples in class, and we'll do some problems with this where if you have access to the population, this would happen a lot in criminology or sociology, when you actually have some sort of characteristic that you've sampled in the population and you're trying to make some inferences about an overarching population. You can do those kinds of tests, and we're going to start by doing some examples of that in class so you learn the formulas. But we don't use that a lot in psychology because we don't know these characteristics of the population. Instead, we're interested in how two groups relate to one another, but it's an extension of this kind of logic. So in the next video, this is the first video of our logical hypothesis testing. In the next video, I'll sort of set that up using the same